we are told that the graph below shows f at x to be a over x plus p plus q, and we are given g at x, which is a straight line. The graph of f, it cuts the y-axis at 0 and 2. So the coordinates here, that's 0 and 2. And then we are told that the asymptote of f intersect at 8. So these are the asymptotes. So we have the x, which is the vertical asymptote. At x, it's minus 2. And we have the y, which is the horizontal asymptote at 4. The graph represents the axis of symmetry. Oh, g at x, it represents the axis of symmetry. Okay. First question, determine the values of A, P, and Q. We need to find the equation of what? We need to find the equation of f at x. Okay, so tell me, what is the first thing that you think you can do to find the equation of f at x? What is the first thing that you can do? What do you think will be best for you to do first? Because already
Find the
you
x
know your
value.
asymptotes, right?
Yes.
So if you know your asymptote from this equation, what are you going to do?
Try to look for the x value.
You, remember, you have P and Q.
Yes.
Remember, this is your P, this is your Q. You can just substitute those values first. So y will be equals to A
You
over.
just substitute values into the formula.
Yes, if your x is negative, when you put it on the formula, it should be positive. So this will be x plus 2. You understand?
Yes.
But the q, which is the y, this one doesn't change. You just put it the way it is. So this will be plus 4. So now we have the equation as y, it's equal to a over x plus 2. And then we have plus 4. What's next? Finding a. So to find a, you can use any given coordinates on the graph, which is this point here, 0 and 2. So we can just sub. Already for doing this, you have 2 marks for substituting P and Q. So to find the remaining 2 marks, we're going to sub in that 0 and 2. Remember, this is your x value, this is your y. On this equation, where there's y, you put 2, and where there's x, you put 0. Then now you can solve for a. So this is 2. The 4 comes this side to be negative 4. And then this will be a over 2. 2 minus 4, that's minus 2. A over 2. We can just cross multiply. This is over 1. This will give us minus 2 times 2, which is minus 4. A times 1, that's A. So you just have to cross multiply to find the value of A. So when you are done, now you have the value of A as minus 4. You have Q as your 4 and P as your positive 2. And this is what you were supposed to do to just get the format.
Yes.
Okay. So determine the equation of the axis of symmetry. So remember, to find the equation of axis of symmetry, to answer this 5.1.2, it's given that y is x plus c, okay? So
Yeah.
you just have to substitute the given x-intercepts. I mean your what is this? You just have to substitute your asymptotes, okay?
Yes.
Remember, the asymptotes are this point, and the point was given as the intersection is minus 2 and 4. So this is minus 2 and 4. Listen, this is your x, this is your y, right? So on the equation, where there's y, we put 4. Where there's x, we put minus 2 to find C. So this guy comes this side to be positive, which gives us 6 to be C. So now that you have C as 6, you take this C, you substitute it back there to get your asymptote. So y will be x plus C. So this is the equation. So this will be the equation of that, of the asymptote. I'm not sure if this makes sense.
It does.
So when you calculate the equation of axis of symmetry, you go to the graph, you look at the point of intersection of your asymptotes, then you substitute it back on the equation. But now let me ask you something. You know that a graph has two asymptotes, right?
Yes.
This graph has another asymptote which will look like this, but it will pass through the same point of intersection, then it will move like that. Look at this. You see this one. This one, it has a positive gradient. This one will have a negative gradient, because if this is you and you are moving left to right, you can see that on this graph you are decreasing, so you'll have a negative gradient. And if this is you, on this graph you'll be increasing. If you are moving in that direction, you are increasing, so that's why it has a positive gradient. So to calculate the equation for this one, we use x plus c. But for this equation, you're going to use x. It's equal to minus x plus c. So the difference is x and minus x. The one with minus x is for negative gradient. So in an exam, when they say calculate the axis of symmetry with a negative gradient, this is the equation to go with. Are you with me?
Yes.
Okay, so now this is a different question. 5.2, let's say we are given f at x, which is 3 over 2 to the power x.
Okay.
So now let's continue and see what we can do from this one. Okay, this is what is given, and they said that give the equation of, on 5.2, give the equation of g at x if g is the reflection of f in the y-axis. Okay, so look at this. If you are reflecting about the y-axis, okay, if you reflect about the y-axis, the x changes. You understand?
Yes.
And if you reflect about the x-axis, the y sign changes. So now the question says about the y-axis, you're going to change the sign of the x. So the new graph, which is g at x, the new equation will be 3 over 2. Where there's x instead of x, you're going to say minus x. Right. But please do not leave your answer like this. Don't leave it as a negative exponent. You understand?
Okay.
So I'm going to remind you the law here. We set x to the n. We can definitely, okay, can you please give me a second?
Okay.
Okay. So now this will be, when we write this is going to be 1 over x to the n without the negative. Can you see that?
Yes.
This graph, I can definitely write this as 1 over, let's say 1 over 3 over, wait, I want to show you something. This will be, I want to write this as 1 over everything without a negative. You understand?
Yeah.
But remember that I can write this as 1 over 3 over 2, everything to the power x, because this 1 to the power x, if I say 1 to the x over 3 over 2 to the x, 1 to the x is just 1. So this brings me back there. Can you see that, ne?
Yes.
So the reason I write this equation is because I need to, I have a lot of fractions. I just have to simplify this into one fraction. And then on top, I have 1 over 1, which is divided by 3 over 2. And everything is to the power x. So now you can see that I can change the division to multiplication. This is 2 over 3. We just flip the fraction, and then this is x. So the final answer, this tells you that the correct answer for this, you don't have to show all this work because this is just one mark. You'll say g at x. I'm just trying to explain them. So
Okay.
from this part, you don't have to show all this work, okay?
Yes, yes.
I'll definitely tell you what to do. So this will be g at x is just 2 over 3 to the x. So to move from this one and go straight to that one, since it is negative, you flip whatever that you have inside the bracket, you change it into 2 over 3, and then you change the sign from negative to positive. This part, I was just trying to explain how we are getting to that part, but there's no mark for all this information. So you can just skip it and just go straight to the answer and say 3 over 2 becomes 2 over 3, but the sign on top changes. So the new graph is just 2 over 3 to the power x. Is this making sense? Are you happy about that?
Yes, sir.
100%.
Yeah.
Okay. So give the equation of the inverse of f in the form of f inverse. So we need to find the inverse. F inverse of f at x. What is this equals to? This will be the log. Remember, this is your base. This is your base. So it becomes the base here on this log. So it becomes the base. This will be 3 over 2. The exponent, we're just going to write it here. Then this is your inverse. Simple. Just like that. You take the base, you write it. You know where the base sits on the log. So it's going to be log x to base 3 over 2. That's the inverse function. Then you'll definitely get that 2 marks for this one. You're still with me?
Yes, sir.
Okay, it's fine. For today, we can stop here. Then what you can do, maybe you can practice. I don't want to do drawing graphs. I don't want to draw, but you can definitely draw the graph, which is an easy thing to do. You know what you need to do when you draw the graph. You're gonna look at this graph here, f at x. So let me just quickly show you how to draw the graph. Then we can call it a day. So if this is my, you're gonna first look at the given graph. They want us to draw f, g, and also what? F, G, and F inverse. Okay, so now let's start with F. The graph of f at x, that's 3 over 2 to the power x. So remember, you have to find the x-intercept if y is 0. So when we find the x-intercept if y is 0, we don't have the x-intercept. You'll see that this is not valid. You can't find the x-intercept because if y is 0, you have 0 to be a 3 over 2 to the power x. There's nothing we can do. We can't solve this equation. Therefore, we don't have the x-intercept. Do you understand?
Yes, sir.
And if that's the case, you will have to find what? You will have to find the y-intercept if x is 0. So the y will be that 3 over 2 to the power 0. Any number to the power 0 is 1. So the coordinates will be 0 and 1. So the graph is somewhere here. There will be 0 and 1. At 1, this is where it casts the y. But now, remember, the graph, if What is this? If we go back to some of the standard form, this is b, this will be ab to the x minus 1. So this is the standard form. If the value of a, listen, can you please on your calculator tell me what is 3 over 2 equals to? You get 1 point something, right? What is 3 over 2?
1.5, sir.
Right. So 1.5 is greater than 1. If your graph is greater than 1, it will look like this. Your shape of the graph will look like this, right? And this is your f. By drawing that, already you have a mark for that. If a is greater than 1, remember here is the value of a. Okay, no, not if a is greater than 1. If b, I'm referring to the value of b because it's the one that has the exponent. I'm very sorry, not a but b. So if the value of b is greater than 1, your graph will look like this. Are you with me on that?
Yes.
And if the value of b is between 1 and greater than 0, then your graph will look like this. Can you see the difference between these two graphs?
Yes, sir.
So now what you're going to do, already you know that G, what was G? From the G was the reflection on 5.2.1. And we said the reflection is this graph here, is 2 over 3. So the reflection, that's 2 over 3 to the power x. This is your G and x. Okay.
Okay.
Okay, so now what I'm going to do, for G, we can find there's no x-intercept, right? So for G, we'll find the y-intercept if x is 0. So it's the same thing. We get 0 and 1. So it will have the same y-intercept, but it will look in the other direction. Why? Because the value of b is between 1 and 0. Tell me, what is 2 over 3 on your calculator? You see that this is between 1 and 0. What do you get?
2 over 3 is 0.7.
Exactly. Then this is the graph of G. Right. The graph of the F inverse. I don't want you to stress, né? The graph of the F inverse. Look at this. You see this. Your F doesn't touch that asymptote. So your F doesn't touch what? It doesn't touch the x axis. So it must not touch x, it's equal to 0. So now to find the F inverse, the asymptote will change into y, it's equal to 0. So the inverse will have the asymptote y is equal to 0. So your inverse must not touch the y. Then you see this point here. This point is 0 and 1. So for the inverse, if you have 0 and 1, to draw the inverse, you interchange the 0 and the 1. This, your x becomes your y becomes your x, meaning that this will be 1 and 0. And this is somewhere here. 1 and 0 is somewhere here. Therefore, your graph will look like this. It must not touch y is equal to 0. Then this will be the graph of the F inverse. Do you have any question based on everything that we've covered today?
No, sir.
All good.
Yes.
You sure?
Yes.
Okay. This is where we can stop for today.
No problem.